practice some more. So hopefully this is recording. Okay, good. All right, guys. So the lesson this week is on infinite limits. And I'm just going to kind of highlight some of the things we talked about. So in this function here, by the way, here's the graph. What happens is I'm coming in from the left of x equals 2. Well, as you can see on the table I showed you that the numbers are getting bigger and bigger for y, but negative. And as I come in from the right, you can see graphically, as I come in from the right, they're getting bigger and bigger positive. In fact, if we go to the next slide, we could argue that the limit on the left, I don't know if it's going to let me write or not. Nope. The limit on the left is negative infinity, and the limit on the right is positive infinity. Does that kind of make sense? Yeah. So we're talking about infinite limits. Now, it turns out that when we have an infinite limit, guess what we're going to get graphically? And I'm going to skip that slide. I'm going to go back to this picture right here. Guess what we call this? A vertical asymptote. Okay? So here I kind of showed you with a little bit of a table. And then here's another example. Again, what's this? Vertical asymptote. Here's also a vertical asymptote. So we can see that when we have limits that go to infinity, we end up with something called a vertical asymptote. And that's the big idea. And I've got some more slides here where I do it algebraically, but I want to get to the definition of a vertical asymptote. So here's using your calculator. I went through that on the slide. Okay, here we go. This is the most important slide on the presentation. How do we define a vertical asymptote? A vertical asymptote is when a function approaches infinity or negative infinity as x approaches some value from c from the left or the right. So in this class, if I ever ask you why is something a vertical asymptote, guess what you need to say? You need to talk about the limit of whatever it is we're talking about as x goes to some value c equaling infinity. Why do you need to say that? Because that's literally how we define it. Okay? Remember we talked about continuity? In terms of continuity, how many things did you have to show? 3 things, right? On the quiz, I won't allow you to say, oh, Mr. Allen, it's continuous because I can draw it without lifting up my pencil. Now, intuitively, that's true, but you have to list those 3 things. So if you want to talk about a vertical asymptote, you have to talk about a limit going to infinity, whether that be on the left or the right. Furthermore, this slide here talks about if you have a function divided by another function where the bottom function, the denominator function, does not go to 0, okay, this is also going to give us something called a vertical asymptote. It's not 0, the function's not 0, but it's going to 0. Do you guys understand the difference between equaling 0 and going to 0? That's something that you need to understand. If I say the limit is 0, does that mean the value of the function there is 0? Not necessarily. We just talked about that on that last example we did. Okay, so for example, I'm giving you the graph of this guy here. What is the limit on the left? What's the limit on the left? Negative infinity. So what can you conclude immediately? It's a vertical asymptote. And what is the equation of that vertical asymptote? X equals -1. This is the equation of the vertical asymptote. In fact, if I go back, that is the equation of the vertical asymptote. Okay? Now, last thing I want to mention here before I turn you guys loose on some practice problems are these, here's more properties. And there's 3 of them. The first 2 are pretty intuitive. Now, if f of x, if we're talking about the limit of f of x, let's let that one be infinity, but then let's g of x be a number like, let's just say 7. Is that okay? Yeah. So here's my question. What is the limit of infinity plus 7? Infinity. Does that make sense? Yes. If I have a humongous number that's so big I can't even write it down, plus 7, it's still, and guys, we don't even understand infinity. You guys can't even begin. I don't even understand infinity. It's so big. But it kind of makes sense that infinity plus some finite value is still just going to be infinity. Would you guys agree with that?
No.
Okay. By the way, what would infinity minus 7 be? Infinity, right? Good. Would you guys agree that's common sense almost, even though you may not quite understand what infinity is? Okay, what if I did infinity times 7? What's that going to be? Infinity. However, what if the limit is less than 0? What if it was infinity times negative 7? That one's going to be negative infinity. So do those two things make sense? Again, I think that those are pretty intuitive. So here's the thing. When we get to the quotient one, guess what answer you want to say? You want to say infinity again, don't you?
Yeah.
But you don't. And I want to illustrate this one here. This one is saying, remember, the g function is 7. So let's say, what's 7 divided by infinity? It's 0. In fact, any number divided by infinity is 0. And I can explain this to you in kind of an easy way. Let me get out of this. I'm going to discard that, and I'm going to come back to here. Okay, so I've got a pizza pie. You guys like pizza? Ooh, there we go. So there's our pizza. If I'm the only person eating the pizza, what fraction of the pizza can I eat?
1.
I can eat 1, right? So in other words, 1 divided by 1 is 1. Agreed?
Yeah.
Okay, what if there's 2 people, though? What if there's 2 people? Half, right? So 1 over 2, right? What if there's 3 people? So now let me erase that. What if I have 3 people eating the pizza now? A third. Okay, so we're going along this way. The number in the denominator is going to get bigger and bigger and bigger, right?
Yeah.
What's happening to the amount of pizza you get as the number of people gets bigger? Smaller and smaller. In fact, imagine this. Imagine there's 1 pizza and then there's, let's say, 10 million people. I want you to think about that. 10 million people. So that's like the size of Los Angeles. So let's say you have 1 pizza and you're going to try to feed 10 million people. How much pizza are they going to get? They're going to get like a crumb or something, right? And by the way, is this number even close to infinity?
No.
So here's my question. Does it kind of make sense why any number, any finite number divided by infinity is 0? Does that kind of make sense? Okay. All right, that was much better than earlier. I'm going to stop.